So here's one idea I had before the term started, that to introduce the notion of dance. I don't know how to dance, and I will not dance in this talk. Okay, but there are some materials in the internet that shows you how to apply these isometries, these 4 isometries, in dancing. Yes, dancing. I will not dance. Well, when I ask my students, can you try to do this as your project? Some is adamant, pinakitaan pa nga ako ng, ganito bang dance ang gusto ko makita? Well, of course, that's not the dance. That's not the topic there. The topic is about reflections, rotations. But yeah, science. May animated GIF yung mga yan. So, mas makikita nyo pa paano move up and down, pati mga curves. Okay. Well, you can actually check the following websites for some ideas on how to apply dancing and mathematics in dancing. Well, this is the website and Math in Your Feet. It teaches reflection of pairs of dancers doing reflective, one mimics the other, or possibly one dance move is being reflected by the other partner and so on. So, you can actually, I have a link here. Ayaw ata. Anyway, but you can actually get the link in mathdance.org. They provide some video clips on their sample dance moves. But the teacher provides that. Okay. So now that we have the idea, the basic concept now about translations, we are ready to talk about symmetric patterns. So by symmetric patterns, what do we mean by that? In the earlier talk, they mentioned about beauty. We see beauty as something that follows a mathematical formula. Maganda ba yung figure ng mukha niya, may input kayo measurements, then kung malapit sa golden ratio, then somehow you look beautiful. Man says so, you're beautiful, even though you disagree, but man says so. Well, these familiar figures, logos, company logos, windows of a church, parts of a rug, carpet rug ninyo, sino na ng Game of Thrones, yung mga logos ng different groups nila. Tinanggal ko lang yung name, I don't know the name. Sabihin bias ako sa isang tribal group doon, but that's the idea. So symmetry, we will talk about symmetry here. So let's talk about symmetries of a square. So I would like to think we have an idea what are the symmetries of a square, but let's show them nonetheless. You have a rotation there, 360-degree rotation, the 90-degree clockwise rotation, point A moves to point B moves to point C, and so on. But the figure stays the same. So the figure did not change. That's the isometry that we want. That's the kind of symmetry that we want, to describe. And there are other types of symmetries, or reflection symmetry. The first row there are your rotation symmetries. Second row would be your reflection symmetries. Well, once we know them, what we would like to do is to form artworks. Well, these are symmetries, patterns. That's the nature of the topic. You produce designs that can be used in forming tiles, in your bathroom tiles, in your throw pillows, and even in your dress shirts, blouses. I see patterns. Kahit yung mga bag ninyo, may mga pattern yan. So, I'll just point out, we define by the design, this is what we mean. By a pattern, this is what we want to say. A design is just a figure with at least one non-trivial symmetry. Hindi yung, yun na yun. You cannot rotate it. It changes in figure. A pattern is a design that has a translation symmetry. A plane pattern has symmetry if there's an isometry of the plane that preserves it. So we will discuss these kinds of patterns. Basically, the symmetric patterns that we will discuss are these three patterns. The rosette pattern, the frieze pattern, and the wallpaper pattern. In the abstract, I did mention that I would like to suggestions. I would like to suggest certain activities regarding these concepts. So some might be trivial, but we can always incorporate other concepts in math. Just like I mentioned, we can include the notion of topics in number theory there. How can we do that? Can we make a pattern out of that? Can we use the notions of groups? Yes, we will discuss groups, but somehow in different levels. So groups will be introduced in rosette patterns, frieze patterns. We construct frieze patterns from certain rosette patterns, or from certain tables that we can construct. So somehow these topics kailangan na medyo konting creative juice sa inyo. Kailangan may keen eye for visualization din. Okay? So what's a rosette pattern? You take a motif. Dr. Lau already mentioned the idea of a motif. It's your figure that you want to manipulate, to construct your pattern by either rotating, reflecting, or translating that pattern. So in this case, we want to rotate it. So by the term rose, no? So rose, yung petals of a rose in the form of circular motion. So we want to rotate a motif to form the rosette pattern. So an example of a rosette pattern, this, a DLSU star. What's the motif there? So if you just look at this point, that point is being rotated 1, 2, 3, 4, 5, 360 divided by 5, what's it? 360 divided by 5, 72. So if I rotate this motif 72 degrees, form this one, another 72 degrees, you form this, and so on. So Same idea here. It's a rosette pattern. This figure is being rotated 120 degrees to form the whole pattern. Well, of course, for a more practical type of pattern, the mugs in your tires, or yeah. So these things, we see them every day. Maybe we just don't realize it's an example of an object in mathematics. It's an example of a rosette pattern, just like the windows of a cathedral. So next, I would like to discuss the types of rosette patterns. Here, we can already include the notion of groups in algebra, or just the simple idea of constructing a group table in algebra. But of course, I did not discuss group theory in math appreciation for CLA students. I just mentioned that they are base names, and you can actually define them in a more abstract way. But of course, we define them in some form, these forms. You might recall what a cyclic group of order n and a dihedral group of order 2n, Pn. So cyclic groups, we just say it's the rosette pattern is a cyclic rosette pattern if it just contains n rotational symmetries. So in our example earlier, the DLSU star is an example of a cyclic rosette pattern of order 5. I have 5 rotational symmetries. I can rotate it in 5 different ways, 72 degrees, 144 degrees, and the figure will stay the same. That's what we mean by this definition of a rosette pattern that's a cyclic of order n. Well, for the dihedral one, the dihedral type, it has a rotational symmetry, but it also possesses a reflection symmetry. So do we have reflection symmetry in our previous pattern? If I consider the colors, the shades, the DLSU star is not dihedral, type of rosette pattern that's dihedral of order 5. Why? If I consider this line that separates the shade here, like the white part and the green part, it's not a reflection of the other portion of the figure. So it's not a mirror image of the half of the figure. So there's no reflection symmetry here. So this is an example. These are examples basically of rosette patterns that are cyclic of some order. Okay. So what are examples of rosette patterns that are dihedral in type? Well, some students would find a pattern out of that. Can we use the notions of groups? Yes, we will discuss groups, but somehow in different levels. So groups will be introduced in rosette patterns, freeze patterns. We construct freeze patterns from certain rosette patterns, from certain tables that we can construct. So somehow these topics kailangan na medyo content creative juice sa inyo. Kailangan may keen eye for visualization din. Okay? So what's a rosette pattern? Take a motive. Dr. Lau already mentioned the idea of a motive. It's your figure that you want to manipulate, to construct your pattern by either rotating, reflecting, or translating that pattern. So in this case, we want to rotate it. So by the term rose. No? So rose, in petals of a rose in the form of circular motion. So we want to rotate a motif to form the rosette pattern. So an example of a rosette pattern is this, the DLSU star. What's the motif there? So if you just look at this point, that point is being rotated 1, 2, 3, 4, 5. 360 divided by 5. 360 divided by 5. 72. So if I rotate this motif 72 degrees, form this one, another 72 degrees, you form this, and so on. So same idea here. It's a rosette pattern. This figure is being rotated 120 degrees to form the whole pattern. Well, of course, for a more practical type of pattern, the mugs in your tires, or yeah. So these things, we see them every day. Maybe we just don't realize it's an example of an object in mathematics. It's an example of a rosette pattern, just like the windows of a cathedral. So next, I would like to discuss types of rosette patterns. Here, we can already include the notion of groups in algebra, or just the simple idea of constructing a group table in algebra. But of course, I did not discuss group theory in math appreciation for CLA students. I just mentioned that they are these names, and you can actually define them in a more abstract way. But of course, we define them in some form, these form. You might recall what a cyclic group of order n and a dihedral group of order 2n, dn. So cyclic groups, we just say it's the rosette pattern is a cyclic rosette pattern. It just contains n rotational symmetries. So in our example earlier, the DLSU star is an example of a cyclic rosette pattern of order 5. I have 5 rotational symmetries. I can rotate it in 5 different ways, 72 degrees, 144 degrees, and the figure will stay the same. That's what we mean by this definition of a rosette pattern that's a cyclic of order n. Well, for the dihedral one, the dihedral type, it has a rotational symmetry, but it also possesses a reflection symmetry. So do we have reflection symmetry in our previous pattern? If I consider the colors, the shades, the DLSU star is not dihedral, a type of rosette pattern that's dihedral of order 5. Why? If I consider this line that separates the shade here, like the white part and the green part, it's not a reflection of the other portion of the figure. So it's not a mirror image of the half of the figure. So there's no reflection symmetry here. So this is an example. These are examples basically of rosette patterns that are cyclic of some order. So what are examples of rosette patterns that are dihedral in type? Well, some students would find difficulty figuring out, provide an example. So, given this, show them that if it's as a cyclic, then you can do this. If it's dihedral, then you can find some sort of a line. This is one line, so you can have a reflection. What's the rotation here? You have a 360-degree rotation. That's one rotation. So this is an example of a dihedral rosette pattern of order 1. Well, basically it's a trivial one. This one, it's a rosette pattern of order 2, the dihedral rosette pattern of order 2. You have one line of symmetry, another line is a vertical, horizontal line here. You have two rotational symmetries, 180, 360. So it's an example of a rosette pattern of that's dihedral in nature of order 2, and so on. So what are the examples that you can see? Well, it's timely because it's December, so I asked my students, there are 3 patterns in the internet that provides you how to construct snowflakes. And snowflakes are examples of rosette pattern. And they have reflectional symmetries, or reflection symmetries. Well, I didn't notice that in my class, there are several students, not just 2, but more than 5, I think, who are a fan of anime. So I got this pattern from an anime, my favorite anime also, Naruto. The eyes of a certain, yes, the Uchiha clan. And yes, they appreciate the idea that I get examples from something familiar to them. Well, this A is an example of a rosette pattern of order 3, but is it cyclic or dihedral? It says cyclic. I cannot get you cannot get any line for reflection there, right? Bakit? Kasi yung bulge na to, mas malaki kaysa dito, no? Hindi pwedeng magkaroon ng reflection doon. But for B, it's a dihedral rosette pattern of order 1, 2, 3, 4, 5. So yung bilangin na, 1 point, no? So those simple rosette patterns, they can classify with dihedral, they can classify with cyclic, but you don't necessarily have to define what a dihedral group is, what a cyclic group is. But for those more curious students, you can ask them what would be the abstract idea of a cyclic group that produces those kinds of symmetries. It's one way to interest those science majors or possibly engineering students. Well, there are more examples of this rosette pattern. Well, some would have cyclic, some would present a dihedral group. Over 3, no? Kasi tatlo yung mga points, diba? And then the rest. Of course, for the GE, the logo of the G, disregard the letter G and E. But just the outer rim there to produce some sort of a cyclic rosette pattern of order 4. Well, this is one of the activity I mentioned. They're creating snowflakes. They can create snowflakes like this. Well, they could get downloadable printable patterns on how to construct those snowflakes. So you can ask them to either produce their own snowflake, describe the symmetries of that snowflake. Maybe those more creative students would give more detail to your snowflake. Merong cut-cut pa dyan, merong hindi naman 3-dimensional, so naka-emboss yung iba. But can interest them more by using common themes like mga girls sa klase, gusto nila rose and snowflake, produce a rose and snowflake like this, or a Mickey Mouse snowflake. Yung iba naman, siyempre, hindi mo pamuli iba mga lalaki doon na lalo na ngayon may nag-plug in ng movie. No? Star Wars themed snowflakes. Sige na. Darth Vader or some stormtroopers. Ay, hindi ba stormtroopers? Si R2-D2 pa rin. And so on. So, you provide them activities, I did provide them activities like this. Iba, hindi nga lang kinalabas na yung output. But the sense is, tinry nilang gawin yung mga activities na kung saan sila interesado. Iba, fan ng Star Wars, kaya mga ganyan ginawa. Well, these are some of the possible activities that you can ask your students na possibly mga engineering students or more science-based students to describe further what are the symmetries of those patterns that they created in or possibly provide a table. So given the symmetries that they see in their snowflake, did they produce another isometry there? Well, that's the idea of constructing now their table. So you're asking them questions as construct a table for this certain group, cyclic group of order 3, but you're not directly asking them to construct the cyclic group, the table, the multiplication table of that group. You're asking them to describe those all possible combinations of their isometries there. So that's just one pattern. What else? The freeze pattern. So basically, freeze pattern is just a long strip of design that you can produce. And these are the repeating patterns. If you see a translation there, a horizontal reflection, a vertical reflection, a rotational symmetry in your pattern, or a glide reflection. So you form your freeze pattern using these isometries, and then they should be able to realize that there are only 7 possible freeze patterns. And they are as follows. A freeze pattern that shows you only this kind of pattern, or a freeze pattern that says this, or this. Mas madali mo tingnan pag nakikita yung mga paa, di ba? Or this one. The 5th pattern is this. A 6th, 7th pattern. So sometimes, hindi man sometimes, madalas nakikita natin mga ganyang class design. Lalo na pag isa niya sa bahay, kaya sa museum. These freeze patterns are usually used as borders of certain artworks or borders of certain designs. Throw pillows in jars, borders of your columns of buildings, or kahit sa mga carpets. They are examples of freeze patterns. What type? Well, check those 7 possible types of freeze patterns. Well, here are more examples. Railings, columns, posts. Okay. So, yes, we can ask them to check examples that examples of freeze patterns they see in their daily lives. But one activity is for them to actually construct those freeze patterns. And here's where we can include those concepts in number theory, group theory, algebra, by using your addition modulo ad integer n. So again, by a modular arithmetic, we just define them as remainders upon division by this number, this integer. So if we get all possible remainders upon division by, say, 3, we only get the following. So that's the addition table of modulo 3. Yes, we see numbers there, but you can also provide colors instead of the numbers. So if you provide them this idea, then you can construct patterns like this by reflecting it here, and then constructing the same by reflecting the resulting figure here to provide this kind of freeze pattern. Muna ay banig. Kaya yung bayo ay yung. But it's an example of a freeze pattern, pattern, that uses the addition table modulo 3. What if you use addition table modulo 4? Then you use this kind of color scheme. Do that process again and produce this kind of freeze pattern. Again, this is a freeze pattern A, but of different modulo. Other possible student activities would be, what if you produce a table modulo a number, but you extend that table? Modulo 4, but I extend the table. Gawa ka lang ng 7. Anong mga possible remainders there upon division by 4? I'm using 7 rows, but I'm dividing it by 4. So getting the remainders there, I get these possible remainders. So I get this kind of table scheme now, color scheme for the table, and produce this kind of freeze pattern. So you can ask them different shapes. What if I have more rows, less modulo? What kind of freeze pattern? What kind of color schemes you can use? Or possibly ask them, are there other ways of representing that table without using colors? You can use other figures, like this one. Instead of modulo 9, I'm using the table modulo 9, but instead of using colors, I use different figures like this. So if you use that figure, these figures as inputs in place of those numbers, we form these kind of scheme or design. But using the same idea, we reflect along a vertical line, and then along a horizontal line, we form the following. That's an example of a freeze pattern of pattern A. But what if lahat puro freeze pattern 8, no? Paano kung hindi ganun yung gawin kong process of constructing the design? I can use this one. I don't want to reflect it vertically. I just want to reflect it horizontally and translate the resulting figure. I would end up with this one. It's a freeze pattern of pattern 5. So same table with different ways of constructing your freeze pattern produces different designs like this. So again, your keen notion of visual thinking of forming designs is part of producing these different patterns. Kailangan medyo meron tayong konting creative juice na isasama sa pag-discover ng iba-ibang mga patterns. Well, I did put some exercise. So, these are examples of freeze patterns, pattern 3, pencils pattern 3. Well, wallpaper pattern are nothing but extensions of your freeze pattern. So, freeze pattern kasi horizontal lang. But strip ang ating construction and design. For wallpaper pattern, we need to cover everything, the whole plane. So, your creative juice is needed here in constructing those type of designs. These are examples. It's found in the book, but I formulate there's one process, an algorithm in constructing wallpaper found in your book. It's this following steps. I use different motif. I use the motif just one. It's a one on Old English way of writing one. But following this motif, reflect vertically, rotate that, rotate, obtain this one, and then you translate or glide reflect to form these kinds of patterns. It should cover everything by continually producing those figures like this. No one limits you in using any kind of motif. So let's just use letter P. Produce this one. Or choose a different font style for P. To produce this one. Same idea, same process of creating a wallpaper that produces different designs because you chose a different motif. Or it would seem abstract, but I just formed this by using a rectangle shaded as green. I cut down a circle colored white. Semicircle cut here. 1/4 of a quarter of a circle is cut on this portion. Another quarter is cut on this portion. It's just a rectangle wherein I cut a circle on different parts of the rectangle and produce using that arrangement again, whether I rotate it in different ways, to produce this kind of wallpaper pattern. So it really is, there is no limit on how you, what kind of wallpaper design that you can produce. Just need a bit of creativity. Okay, sabi ko kanina, kailangan natin ng konting creative juice pag-construct ng mga ganitong klaseng design. Well, I would like to end the talk here. So, if you have questions. Are there any questions? Or any comments?
Probably people, they're interested in knowing how they can present this in such a way that you can possibly suggest some sort of a software. How to generate that? I don't know.
These patterns, yung color niyan, sa paint ko lang gawa. Yung pag-rotate, sa Word kasi may mga options na pwedeng rotate yung mga figures. Ito ko lang gawa. Wala namang special software na gagawin. Ang specialty software na siguro yung pag-picture dun sa na-photo para makulayan. Kasi pag nasa Word lang, kaya makulayan naman. So, then sa paint ako.
Pero kung yan ay mas okay yan tayo pero tayo na yung pag-zone sa university.
MS Word lang talaga ng paint.
Kasi apply
Para at least maano ko na pwede na rin gawin. Yes, for those who have Adobe Photoshop, it would be better. Kasi mas madaling mag-manipulate ng figures doon. Mas okay yun. So, well, you have balance software. Yes, mas accessible to paint at work. Hindi kasi ako magaling mag-hand drawing, kaya kailangan ng aid ng computer. Dahil na paulit-ulit ko din gagawin. Kailangan ng okay? Yes, I think mag-upload ata kami ng slides on the website. So you can get the slides.
Thank you, Mr. So, to award the certificate of appreciation, may I call on one of the chair of the organizing the DLSU Mathematics Department awards the certificate of appreciation to Francis Joseph Campeña for his speaker during the DLSU Mathematics series on the topic Mathematics and Power held at the Chapter Center in December 11th, signed by the chair of the Mathematics Department, chairs of the organizing